Eventually, we've come to the end of the derivation of the laws of what logarithm. Why? Because we're looking at the very last addition, or part known as part 10. And of course, in this particular part, we shall be deriving what is called the 10th law of logarithm. It's not like a law, but at least a conditional statement, and it says that if and only if, yes, the 10th conditional logarithm statement says that if and only if the log of a to base m is equals to the log of b to base m, then the log to base m here will strike this. Therefore, it is true that a is equals to b. So this is what we intend deriving. The task in this particular video is to authenticate that indeed, if log a to base m is equals to the log of b to base m, automatically a is equals to b. To do that, we say, are you there? Given that the log of a to base m is equals to the log of b to base m. Let's call this equation number 1. Now, let us use x to represent okay, let us use x to represent this part of the equation. That is, x is equals to the log of a to base m. Now, going by one of the laws that I derived, one of the laws of logarithm, we've been able to establish, I think that should be, if not the fourth or the fifth law, that law says that the log of a to base b is equals to the log of a to a new base divided by the log of b. So let us recall to that law. There's a law that says that the log of a to base b is as good as the log of a to a new base. You can as well exclude the base if you want to include it. That means you indicate it on the both part of the equation, that is log b to base m. But if you don't want to include it, you can just delete it here and as well delete it here. So the log of a to base b is as good as log a divided by log b. Very correct. So if that is the case, it means that log a to base m automatically becomes our x now becomes the log of a, are you there, divided by the log of m. Now we call this equation number 2. Now similarly, what we did to this part of the equation, let us do it to this part of the equation. Where s is representing this, let us use y now to represent this. So we say let y represent the right hand part of the equation, which is log b to base m. If that is true, automatically, are you there, y becomes y becomes the log of b, are you there, divided by the log of m. And I will call this equation number 3. Equation number 2 is equals to equation number 3. Why? Because log a to base m is equals to log b to base x is equals to y. But we know that x is equals to y. Therefore, equation number 2 is equals to equation number 3. Equation number 3. So if that is the case, wherever I see equation number 2, I'm going to put log a to base log of a divided by log of m, and wherever I see equation 3, I'm going to be including or substituting in log of b divided by log of m. So doing that, we'll have the log of a, right, divided by the log of m is equals to a log of b divided by the log of m. Now there's a law that says that top cancel top and bottom cancel bottom. So the button here will cancel this button. Are you there, leaving the log of a to be equals to the log of b. The log here will strike the log here. So what is left is a, and that is equals to b. So indeed, if and only if the log of a to base m is equals to the log of b to base m, one can therefore conclude that a is correctly equals to b, which I've been able to validate in this particular video. Please do not hesitate to like, share, comment, and of course follow my page for more difficult equation in mathematics, and of course their derivation. God bless you, and I love you.